Hi, in this problem, we'll continue our series of advanced problems for JEE Advanced basically. And today we are looking at two questions which are part of a single paragraph. So this is problem 49 and problem 50 in our series. So let's look at this particular question. Here we have a paragraph here. We have four functions which are defined, psi1, psi2, f and g over positive real numbers from 0 to infinity to r. And these functions, there are some properties that are given. F of g0 is equal to g of 0 is equal to 0. Psi1x is defined as e power minus x plus x for x positive. Psi2x is defined as x square minus 2x minus 2 e power minus x plus 2, again for positive x. F of x is defined via an integral, a definite integral from minus x to x of mod of t minus t square e power minus t square. And this is again for x positive. Similarly, g of x is also defined as an integral. Now the question is asking us which statement is true. F of root ln 3 plus g of root ln 3 is 1 by 3. And then we have two statements about psi1x and psi2x. So what we will do is we'll look at each of these options one by one. So before we do anything, let's try to understand what is this f of x and g of x, because they are defined in terms of integrals, right? So let's try to figure out the derivative of this f of x. So because of Newton-Leibniz formula, we can immediately differentiate the integral, right? So I'll do it on the next screen. So f dash x will become basically mod of x minus x squared e power minus x squared plus minus the lower limit you'll put mod of minus x minus x square e power minus x square multiplied by the derivative of minus x, which is minus 1. This part was easy because you were multiplying it with the derivative of x, which was 1, right? So if you simplify this, you should realize that this mod of minus x is same as mod x. This is same as x square. And this part is also e power minus x square itself. But this minus 1 makes it a plus. So you have the same term appearing twice here. So f dash x is becoming equal to twice of mod of x minus x square e power minus x square, right? And this was defined for x greater than equal to 0. That was given in the definition of f of x, right? So if you think about it, for x greater than 0, mod x is equal to x. So this is basically x minus x square. And we can basically understand what is the way in which this bracket changes sign. We already know that e power minus x square is always positive. So if 0 is less than equal to x is less than 1, then x is greater than x square. So therefore we have f dash x is equal to 2 times x minus x square e power minus x square is greater than 0. And for x is greater than equal to 1 or greater than 1, x is less than x square, and therefore f dash x is equal to 2 times x minus x square e power minus x square is less than 0, right? So what we know from here is that immediately we are getting that f dash x is positive for 0 to 1 and is negative for 1 onwards, right? F dash x is negative 1 onwards. So what we understand from here is that f of x increases from 0 to 1 and decreases from 1 to infinity, right? So f of x is decreasing from 1 to infinity, and one of the options was f of x is increasing from 0 to 3 by 2. So we know that it increases from 0 to 1, not 0 to 3 by 2. So D option becomes wrong. D option is incorrect for us. So one of the options we have worked out by simply finding f of x and its derivative and understanding the nature of that function f of x. Similarly, let's try to evaluate what is g of x. So g of x was defined as integral of 0 to x square root of t e power minus t dt, and this was true for x greater than 0. So if I try to do g dash x here, again by Newton-Leibniz formula, we get root of x square e power minus x square into 2x. That's it, right? And since x is positive, root of x square is plus x. So that is x e power, so 2x square e power minus x square. This is my g dash x, right? Correct. Now, if you look at your f dash x was what? F dash x was 2 times x minus x square e power minus x square, and g dash x is coming as this. So you can see that f dash x plus g dash x is equal to, if you notice here, the 2x square e power minus x square will get cancelled, and you will end up with 2x e power minus x square, right? 2x e power minus x square. If you add the two derivatives, this is what you get for f dash x plus g dash x. Now, this is easily integrable. You can integrate on both sides. You can say integral of f dash x plus integral of g dash x is equal to integral of 2x e power minus x square, and integral of f dash x is f of x plus g of x. We get integral of this is also very easy because x square can be taken as t. So this is e power minus t and dt, right? So this becomes negative of e power minus x square plus some integration constant, right? So we have this result now, and we also know from the beginning of the problem that f of 0 is g of 0 is equal to 1. That was is equal to 0. That was given in the data itself. So if I put 0 here, I will get 0 plus 0 is equal to minus 1 plus c. Therefore, c is equal to 1. So now I get this result, fx plus gx is equal to 1 minus e power minus x square, right? So fx plus gx is coming out to be this. Now we can check option A. Option A was f of root of ln 3 plus g of root of ln 3. And we have to evaluate that option, right? So what will we get here? If we put x is equal to root of ln 3 here, we'll get 1 minus e power minus root of ln 3 whole square will be ln 3. So this will be ln 1 over 3. So this will be 1 minus 1 by 3, which is equal to 2 by 3. And the option was saying that this was equal to 1 by 3. We are getting is equal to 2 by 3 because we have figured out by solving the differential equation that fx plus g of x is equal to 1 minus e power x square. 1 minus e power minus x square. So our option A is also incorrect. So far we have gotten A and D are incorrect. And now we have to think about options B and C. So notice one thing here, how did we get this second A option? We didn't try to directly put fx and gx f of l root of ln 3 in the equation itself because that complicates matters. We did it in an indirect way. We figured out the derivatives first, and we saw a nice condition on the derivatives. F dash x plus g dash x was equal to this, which can easily be integrated. And then you will get an expression of the form fx plus gx, right? So we have eliminated A and D option. Now we have to look at C and B options, right? So the B option was talking about for every x greater than 1, there exists an alpha belonging to the interval 1 to x such that you have psi 1 x is equal to 1 plus alpha x. Now what information did we know about psi 1 x? We know that psi 1 x is equal to e power minus x plus x for x greater than equal to 0. So in order to figure out this part, what we will take is we'll define a new function h of x. Just like the last video that we did, we were defining a new function to try to get whether an equation has a solution or not in a certain interval. We are doing a similar idea here. We are saying h of x is equal to, let's say, psi 1 x minus e power. Okay, we have to prove this, right? So let's just define it psi 1 x minus 1 minus alpha x. Let's define this as my function. We have to check whether this is true or not. So technically we have to check whether h of x is equal to 0 or not in this interval, when alpha lies in this interval for every x greater than 1, right? So here we know we have defined h of x as psi 1 x minus 1 minus alpha x, and psi 1 x was what? That was e power minus x plus x minus 1 minus alpha x. This is my h of x. And we are saying that this is true for x greater than equal to 1 and alpha belongs to 1 to x. Right? Now let's think about what is h of 1. What is h of 1 here? H of 1 will be e power minus 1 plus 1 minus 1 minus alpha. So that becomes basically e power minus 1 minus alpha. This is 1 by e minus alpha. So 1 by e is less than 1 and alpha is greater than 1 because alpha lies in the interval 1 to x. So this implies that h of 1 is less than 0. Correct? Now what is our h dash x? Derivative of this h of x function minus e power minus x plus 1 minus alpha. Right? So if you think about it, this is negative and 1 minus alpha is also negative because alpha is greater than 1 and this is negative. So h dash x basically comes out to be less than 0, which means that hx is decreasing. Hx is decreasing for x greater than equal to 1, where this condition was defined, right? If hx is decreasing for x greater than equal to 1 and h1 is already less than 0, then we can say that hx will always be less than 0. See, the starting point of the interval, the h function is already negative, and we have shown that it is further decreasing. So it can never become 0, right? It will always be less than 0. So since it is always less than 0, this equality cannot happen. This equality cannot happen because h of x is always less than 0 in this interval, right? So now we have basically shown that option B is also incorrect. Here we have used the properties of the function. We have defined an auxiliary function and checked the nature of the monotonicity of that auxiliary function in the interval where x is greater than equal to 1, right? And we found that it is always decreasing and the starting point was also negative. So it can never be 0 and therefore psi 1 x can never be 1 plus alpha x. Okay, and lastly, we look at the final option where again we have a similar type of question where for every x greater than 0, there exists there exists a beta belonging to 0 to x such that psi 2x is equal to 2x times psi 1 beta minus 1. We have to show this, right? Or we have to check whether this is correct or not, right? So we are saying psi 2x, let's consider the function psi 2x which is equal to 2 times psi 1 beta minus 1, right? And we can apply Lagrange's mean value theorem to the psi 2x function. So mean value theorem says that if the function is continuous and differentiable in an interval, and our interval here is 0 to x, over the interval 0 to x, then there is a point in the interior of that interval where the derivative or slope of tangent to the curve at that point will be equal to the f of b minus f of a by b minus a, right? So we can say that there must be a point psi 2 dash beta. Let's say beta is the point, right? There must be a point psi 2 dash beta is equal to basically psi 2 x minus psi 0 psi 2 0 by x minus 0, right? So we are applying Lagrange's mean value theorem to this psi 2 function, and we are saying that there must be a beta in 0 to x such that the slope of the tangent to that curve must be equal to the average slope of the function as it varies from 0 to x, which is this f of b. This is the f of b minus f of a by b minus a. LMVT was like there is a c such that f dash c is f of b minus f of a by b minus a. That is what we are applying, right? Now notice here psi 2 of 0. Psi 2 of 0 is actually equal to 0 because psi 2 function was actually defined. Psi 2 of x was what function? It was x square minus 2x minus 2 e power minus x plus 2. So it is clear that psi 2 of 0 is 0 minus 0 minus 2 plus 2, which is 0. So we are getting this is equal to psi 2 x by x, right? So psi 2 dash beta is equal to this. Now we have to calculate what is psi 2 dash x. Psi 2 dash x is what for us? Differentiate this, we get 2x minus 2 plus 2 e power minus x. This is what we are getting. So psi 2 dash beta would be 2 beta minus 2 plus 2 e power minus beta, right? Is equal to psi 2 x by x, right? So we will write on the next screen 2 beta minus 2 plus e power minus beta plus 2 e power minus beta. That is my psi 2 dash beta should be equal to psi 2 x by x, right? So what we are getting is psi 2 x is equal to 2x beta minus 1 plus e power minus beta, right? Beta minus 1 plus e power minus beta. Now think of what this is actually. If you think of your psi 1 x function, that was what psi 1 x was e power minus x plus x, right? So obviously psi 1 of beta minus 1 would be, or simply correct, psi 1 of beta minus 1 would be e power minus beta minus 1 plus beta minus 1, right? Yeah, I have made a mistake. I had to prove not psi 1 beta minus 1. It was psi 1 of beta whole minus 1. That is what I had to check the options, right? So psi 1 of beta is e power minus beta plus beta, and whole minus 1 gives us beta minus 1 plus e power minus beta. So this part is actually what? 2x. This is psi 1 of beta minus 1. So we have shown that psi 2x psi 2x was this, and correct. So we got psi 2x by x was this, right? And we brought the x on this side, cross multiplied. We wrote 2x, and this inside part we have shown is equal to this. So this is my option C, and option C is coming out to be correct. The trick to applying or understanding option C is basically applying LMVT to psi2x over the interval 0 to x. And afterwards, you have to notice that the thing inside the bracket that came here, that is actually psi1 beta minus 1. And then you get the option. So hopefully you have understood this particular problem. For the same paragraph, we have now a different question, which is again a multiple correct option question possibly. So we have, which of the following statements is true? Which of the following is true? Basically, the first part is saying psi1x is less than equal to 1 for all x greater than 0. The second option is saying psi2x is less than equal to 0 for all x greater than 0. Third option is fx is greater than equal to 1 minus e power minus x square minus 2 by 3 x cube plus 2 by 5 x power 5 for all x belonging to 0 to half. And finally, fourth option is g of x is less than equal to 2 by 3 x cube minus 2 by 5 x power 5 plus 1 by 7 x power 7 for all x belonging to 0 to half. Okay, so we'll start off with the easy steps here. We know that psi1x was what? E power minus x plus x. Psi1x is e power minus x plus x for x greater than equal to 0. So what is the derivative of this? Psi1 dash x is minus e power minus x plus 1. Now think about it. If x is positive, this is 1 minus 1 by e power x. So obviously this is greater than 0, right? So psi1 x is coming greater than equal to 0. Psi1 dash x is coming greater than equal to 0. Therefore, psi1 x is increasing. So psi1 x is an increasing function, and we know that therefore for x positive, we know that psi1 x will be greater than psi1 of 0. Right? Because it's an increasing function, psi1 x will be bigger than psi1 0. So you will have basically psi1 0 is what? Psi1 0 is basically 1. We get psi1 x is greater than equal to 1, which is incorrect because option 1 is saying that, I mean, this is correct and option 1 is incorrect, right? Because here the claim is that psi1 x is less than equal to 1. So that completes option 1, checking option 1. Option 2 can be checked in an exactly similar way. Just find out the nature of the psi2 function, do a derivative of psi2. You will end up getting, we had psi2x was equal to x square minus 2x minus 2 e power minus x plus 2 for x greater than equal to 0. So if I take a derivative here, psi2 dash x, that becomes 2x minus 2 minus minus, so plus 2 e power minus x, right? Okay, now here this is equal to 2 times x plus e power minus x minus 2. And if you think about it, x plus e power minus x was psi1 x. So it is 2 times psi1 x minus 2, right? But we already know that psi1 x is greater than equal to 1. We just did that proof right now. So this is obviously 2 times psi1 x will be greater than equal to 2. So this is greater than equal to 0. So we know that psi2 x is also increasing. Psi2 x is an increasing function, and therefore psi2 x must be bigger than psi2 0, right? Must be bigger than psi2 of 0. What is psi 2 of 0? If you put 0 here, you get 0 minus 0 minus 2 plus 2, which is equal to 0. So we are getting psi 2x is greater than equal to 0. Again, that contradicts the option 2. So option 2 is also incorrect. Again, notice that when we did derivative of psi 2 dash x, we use the fact that it can be written like this, and we already know that psi 1 x is increasing function and starts its values from 1. So we were able to get this very easily. So option 1 and option 2 are incorrect. Now we look at option 3 onwards, right? So think about it. F of x was defined as integral of minus x to x mod of x minus x square and e power minus mod of t minus t square e power minus t square dt for x is positive, x greater than 0, right? Okay. Now you can think about this and realize that this is an even function. If you replace t with minus t, nothing changes in this integrand, right? It is mod minus t same as mod t. T square will remain unchanged. So this is an even function. So we can write it as twice of 0 to x mod of t minus t square e power minus t square dt. We are using the property of definite integral to say that for an even function, the interval can be split into two parts and you can say twice of this smaller integral, right? Okay. Now, if x is belonging to if x is less than 1, right? We have mod of t minus t square is going to be basically positive because this is simply t minus t square e power minus t square dt. Since we know that x is positive, so t goes from 0 to x. So here what we can do is actually we can simply try to integrate this, right? Right, we can split it apart and write it as 0 to x 2t e power minus t square minus 0 to x 2t square e power minus t square dt, right? I have split the integral into two parts and this integral is obvious. The derivative, the integral of this can be done by t square is equal to u. You will get minus of e power minus of x square or t square and the limit is 0 to x here. And for the second integral, this can also be done. This can also be done by okay, we'll keep the second integral as it is. Let's calculate this part first. This part is becoming what? Minus e power minus x square minus minus plus 1. So you're getting 1 minus e power minus x square minus integral 0 to x 2t square e power minus t square dt. That is my f of x, right? Correct. Right. I mean, we can actually evaluate this integral by doing integration by parts probably. Or you can also do a series expansion here. So right. Okay, I will keep it as it is for now. I have f of x is equal to 1 minus e power minus x square minus integral 0 to x 2t square e power minus t square dt. And I will define a new function h of x. H of x is equal to f of x minus 1 plus e power minus x square plus 0 to x 2t square e power minus t square dt. Let's try to find out what happens if we do h dash x. H dash x is f dash x f dash x, and this term would be minus 2x e power minus x square plus, when we put here we get a plus 2x square e power minus x square. Okay, yeah, we get this term, and now we can say it is f dash x minus 2 e power minus x square. It is x minus x square, right? And remember, we had solved earlier f dash x was equal to what? F dash x was equal to 2 times x minus x squared e power minus x squared, right? Correct. So you are getting h dash x we have to evaluate this function, right? How do I integrate this? One way to try to get a rough integral also here would be expansion of e power minus t square would be 1 minus t square by 2 plus t power 4 by 1 plus x square by 2 factorial. So x is minus t square. So x square is this by 2 factorial. So it is not by 2 here. So 2 factorial will come here. And higher terms, right? So 2t square times 1 minus t square plus t power 4 by 2 factorial and so on will become basically 2t square minus 2t power 4 plus 2t power 6 by 2 and so on. So the integral of this term by term integration, if we do, we will get t cube 2t cube by 3 minus 2t power 5 by 5 plus t power 7 by 7, right? And if you evaluate it from 0 to x, you will get 2x cube by 3 minus 2x power 5 by 5 plus x power 7 by 7 and so on. This is an infinite series, I understand that, but if your x is less than 1, these terms will become very small, right? The x power 7 by 7 terms will become really small. So you can say in that case, if your x is less than 1 in that region, we can say that h of x h of x is becoming fx minus 1 plus e power minus x square plus this part is 2 by 3 x cube minus 2 by 5 x power 5, and we can ignore the higher order terms here, right? So if you do that, this is for x belonging to 0 to 1. Now if you do h of 0 here, h of 0 is f of 0 minus 1 plus 1, and all of these terms will become 0. So f of 0 was what? F of 0 was 0, right? So h of 0 is also 0, because you're getting 0 minus 1 plus 1 and other terms are vanishing. So you're getting h of 0 is 0, and we will get basically h dash x. What is h dash x? H dash x will become 2 times f dash x is 2 times x minus x squared e power minus x squared, and then we get a minus 2x e power minus x squared, and we get a plus 2 by 3 into 3x squared. So it is 2x squared minus 2x4 and higher terms, right? So h dash x is basically this plus 2x into e power minus x square cancels with this. So you get a minus 2x square e power minus x square and a plus 2x square minus 2x power 4, right? So what we can say is we can take 2x square common here and we get a 1 minus x square minus e power minus x square, something like this. And you can see clearly that this part is going to be, if x is less than 1, this part is positive, right? We know that e power minus x think about this part of it. We have 1 minus x square minus e power minus x square. Okay. Is it negative for small values of x? Yes. Because x near 0, what is happening? Near 0, what you are getting is 1 minus 0 minus 1. It is 0. Correct. Right. This quantity is negative. This quantity is negative. So you are getting h dash x is less than equal to 0. And that means that h of x is decreasing. H of x is decreasing. So if h of x is decreasing, then h of x would be lesser than h of 0, right? It is decreasing function, but h of 0 is 0. So h of x is less than 0, we are getting. So that means that we can now say that f of x, what is, we have h of x is less than 0. So f of x, what is f of x? Is less than equal to 1 minus e power minus x squared, right? So we are able to show that f of x minus 1 plus e power minus x squared minus plus 2 by 3 x cube minus 2 by 5 x power 5 is less than equal to 0. So f of x is less than equal to 1 minus e power minus x squared minus 2 by 3 x cube plus 2 by 5 x power 5. So this basically proves that option C is also incorrect. Option C is also incorrect. So option D must be the correct answer here. In order to prove option D is correct, you can approach it in the same way. use the expansion of e power minus x square and try to prove, basically I will show you the outline for what you need to do for option D. So we need to show that g of x is less than equal to 2 by 3 x cube minus 2 by 5 x power 5 plus 1 by 7 x power 7 for all x belonging to 0 to half. So what you can do here is define a new function p of x. P of x is equal to g of x minus 2 by 3 x cube plus 2 by 5 x power 5 minus 1 by 7 x power 7. And this is for x belonging to 0 to half. Right? Now find p dash x. P dash x is g dash x minus g dash x minus 2x square plus 2x power 4 minus x power 6. What was g dash x? We had calculated g dash x earlier. That was equal to x 2x square e power minus x square. So we have minus 2x square plus 2x power 4 minus x power 6. Right? Now, the best way to simplify and know whether p dash x is positive or negative is to do the expansion of e power minus x square. So it is 2x square 1 minus x square by 1 plus x power 4 by 2 minus x power 6 by 3 and so on minus 2x square plus 2x power 4 minus x power 6. This calculation, if you do, you will notice that 2x square gets cancelled with this term. Minus 2x power 4 will also get cancelled. And x power 6 will also get cancelled. So you'll be left with minus 3 factorial this is. So minus 1 by 3 x power 8 plus x power 10 by 12 and so on. This is what is coming as p dash x. And now clearly for x belonging to positive 0 to half, p dash x is less than 0. And if p dash x is less than 0, then px is a decreasing function. So px is decreasing. So if px is decreasing, we can say that p of x is less than p of 0. Right? And what is p of 0? P of 0 is simply 0. So we get p of x is less than 0. Right? And p of x is less than 0 means this is less than 0, which means gx is less than this part. Right? So option D comes out to be correct. There was some confusion in option C, but I realized later that we just have to do the series expansion and do it. Right? So try it yourself again, see if you are getting the value. Question was a little complicated because so many options were incorrect and we had to verify all of them. Right? But the basic idea is pick an auxiliary function, try to get the derivative of that function, and then understand whether it is increasing or decreasing. Right? So that's all for this video. We will continue with more problems tomorrow, and hopefully you learned something from this video. Please like the video and subscribe to the channel. I'll see you next time.